Welcome to another episode. Today we're looking at IEB May 2023, paper 1, question 10b, right, where we have a cubic graph. In the diagram below, B is one of the turning points of the cubic function h, right? Find the values of a and b if h of x is equal to x cubed plus ax squared plus bx plus 36. Now, this is something that I mentioned in another episode, right? We have two unknowns that we're trying to figure out, and so we're going to need two bits of information to help us figure out what they are, right? So we need to look for two bits of information that have been provided to us. The first one is that what is stated in the question. B, the point B, is a turning point, right? And we know that turning points we find by taking our first derivative, the first derivative of the function, and equating it to 0. So the turning pointness of the turning point is giving us a bit of information that we can use to set up some kind of an equation. The second bit of information that's going to help us out is a bit elusive, but it's the fact that we have a point -1 and 44 on the graph. Remember that what this is telling us is if I put the value, the x value -1 into the function, right, -1 cubed plus a times -1 squared, etc., etc., the output of the function will be 44. So this is the second equation that we can set up in order to solve for a and b. So let's get into it, right? So let's set up the second equation that I talked about, right? This question is telling us that h of -1 is equal to 44. If I input x is equal to -1, the output of the function is going to be 44. So what does that look like as a more fleshed out equation? So we're going to say -1 cubed plus a times -1 squared plus b times -1 x plus 36. Okay, we have run out of space, y'all. Maybe let's do this. It's gonna move everything. Okay, maybe let's take this one. Oh, interesting things. Right, okay, I think I might just need to start from the bottom. Okay, or just move things a bit painstakingly, hey? Okay, let's move that much. And then I'll just rewrite the other stuff. Okay, so we've got h of -1 is that, and then over here we have -1 cubed. Right, let me try and move that again actually. Good. So let's simplify. Is equal to, right? So if I put -1 into x cubed plus ax squared plus bx plus 36, right, the output is going to be 44. Okay, so simplifying the terms, -1 cubed is -1, and then we've got a times -1 squared, so a times +1, which is just a, and then we've got b times -1 times x, so we're going to end up with a negative bx. Oh, why is there an x? Sorry. Why is there an x? We're replacing all the x's with negatives. With -1. Sorry, my bad. Right, so there shouldn't be an x because the x in that term has been replaced by -1. So, right, plus 36 is equal to 44, right? And if we add these two together, we end up with a minus b plus 35 is equal to 44, right? And the only way for that to be true is if a minus b is equal to 9. Right, so again, we're solving for two unknowns. We're going to be using simultaneous equations. So let me just note this in the corner somewhere. This is going to be our first equation. Okay, and I'll write it down over here as well. So let's move this away. Okay, I hope that doesn't grab the picture. Oh! Can I not cut? Okay. Right. Let's move this to the next page. Right, so that's our first equation. The second one we said is going to come from the information about B being a turning point, right? So first we're going to need to find the first derivative of H, right? So H prime X is equal to 3x squared plus 2ax plus b, and then the constant disappears, right? And what we have been told is that h prime, if I put in x is equal to minus 1, the result of the first derivative is going to be 0. That's the only way that x is equal to minus 1 would be where a turning point occurs, right? So what that means is if I put in minus 1 here, right, the outcome is going to be 0. So let's simplify this. 3 times negative 1 squared. Negative 1 squared is positive 1. 3 times 1 is just 3. And then over here we have 2 times a times negative 1. So we're going to end up with a negative term. Right, so we end up with minus 2a plus b is equal to 0. And then just so that it looks like this equation as well, where we have a and b on one side and a constant on the other, I'm going to minus 3 on both sides. All right, so we end up with negative 2a plus b is equal to negative 3, right? And that becomes our second equation. So I'm going to just take note of that as well. Negative 2a plus b is equal to negative 3. Okay, and let's move this guy down. Just love how eager the calculator is to show up. Oh, what have I done? I don't know, that's how I can take a screenshot. My gosh. Wow, we live and we learn, guys. Okay, now I can't use that corner. Yeah, it's like everything's untouchable. If I come to this corner, the calculator wants to come out. What a time to be alive. Okay, let's see if this is looking good. Yes, it is. Okay, so let's move it. Okay. Right. So we now have two equations in terms of a and b. We have a minus b is equal to 9 and minus 2a plus b is equal to negative 3. So let us now solve these simultaneously. I've said before that I love the process of elimination, but maybe just to spice things up, let's use the process of substitution. So we're going to let's take the first equation and express it, make a the subject of the equation. All right, so that would mean a is equal to 9 plus b. And let's make that equation number 3. Wow, that is bright, isn't it? Maybe let's use a tamer color. So sub 3 into 2, okay? So then we have negative 2, and we're going to replace the a with the expression in terms of b, right? Minus 2 times that plus b is equal to negative 3. So then we have negative 18 minus 2b plus b is equal to negative 3. So let's add 18 on both sides to get rid of this guy. So we'll have, okay, let's simplify this as well. Minus 2b plus b is just minus 1b, okay? And minus 3 plus 18, or 18 minus 3 is positive 15. And therefore b is equal to negative 15, right? So we now know what b is. Let's then work out what a is. Okay, so sub that into equation number 3 or equation number 1 or number 2, whatever, right? A is equal to 9 plus negative 15, which is negative 6, right? And you know by now, sanity checks are my favorite thing, okay? Just to see if your calculations are still, they got integrity. So if we take a is equal to negative 6, b is equal to negative 15, and we put it into this equation, for example, then we should get minus 2a plus b equaling minus 3, right? So let's try it out and see. So sanity check. Okay, negative negative 2 times negative 6 plus negative 15, right? So this over here is positive 12. And then if we add negative 15, so positive 12 minus 15, that gives us negative 3. Yay! Hooray! Okay, that just ended with a weird looking pencil, right? But yes, we now kind of have some assurance that our values for a and b make sense. Right. Oh, and that's it. We have our value for a and we have our value for b. A is equal to negative 6 and b is equal to negative 15. Perfect.